So the last thing we're going to talk about in right triangles is application of trig ratios. So this means word problems. So there's some key words or phrases in application problems that are going to help you figure out where your angle goes, what side of the right triangle you're solving for, so you know which trig ratio to use. So the first one is angle of elevation. So the angle of elevation is from the horizon looking up. So if you're looking at this right triangle, that would be the bottom right angle. That's our angle of elevation. Okay. Your angle of depression is the angle equal to the angle of elevation. So that means if you're at the top of something and you look straight out, then you look down, that's your angle of depression. And it actually falls outside of a triangle. It's not inside the triangle. So this is our angle of depression. Okay. So the next thing are some keywords to help us figure out what we're trying to solve for. So if you're away from, that means you're horizontal. So that would be along the bottom of your right triangle. Rises is vertical. Leaning is your hypotenuse. Above the ground, also vertical. Shadows are horizontal. And then anytime you're solving for the length of a kite string, a ladder, a wire, a slide, so lengths of things tend to be hypotenuse. So let's go ahead and do some examples. So at a certain time of day, Lindsay's shadow is 9 feet long. If the angle of elevation of the sun is 32 degrees, how tall is Lindsay? So it's always kind of helpful to kind of draw a picture of what your problem looks like. So we've got our sun and we've got Lindsay. Okay. We know her shadow. So this is her shadow. We know the angle of elevation to the sun, 32 degrees, and we want to know how tall is Lindsay. So the shadow is 9 feet. So we're solving, so based on this right triangle, we are solving for the opposite side, and we have our adjacent side. So that means that we're going to be doing tangent. So we have tangent of 32 equals the opposite side x over 9. So to solve for x, we're just going to multiply both sides by 9. And we're going to get 5.6 feet. In our second problem, we have that a 13-foot ladder is leaning against a house. The bottom of the ladder is 5 feet from the base. What angle does the ladder make with the ground? So I'm going to draw a lovely house. We have a 13-foot ladder. So when we talk about 13 feet, that is the length of the ladder. The bottom of the ladder is 5 feet from the base of the house. We are solving for the angle the ladder makes with the ground. So that's the angle on the bottom. So we have the adjacent side and we have the hypotenuse. So that means we're doing cosine of theta equals 5 over 13. So our angle is the cosine inverse of 5 over 13. So our angle is 67.4 degrees. In our third example, we have Parker is flying a kite. The kite string is 30 yards long. If Parker is sitting on the ground and holding the string at an angle of 42 degrees, what is the height of the kite? So we're going to have Parker. He is sitting on the ground. He's got his string that goes to his kite. We know with the angle with the ground is 42 degrees. The length of the kite string is 30 yards. The height of the kite is how far it is off of the ground. So we are solving for the opposite side, and we have the hypotenuse. So we're using sine. So sine of 42 equals the opposite side x over 30. So to solve for x, we're going to multiply both sides by 30. And we're going to get that the kite is 20.1 yards off the ground. In our last example, we have that a fishing boat is 200 meters from a cliff. A hiker is sitting at the top of the cliff and looking down at the boat. If the cliff is 150 meters tall, what is the angle of depression of the hiker down to the boat? So we have our cliff with our hiker sitting at the top. The fishing boat, so it's in the water. And it is 200 meters. If you are looking down, this is your angle of depression. It is technically outside your right triangle. And then our cliff is 150 meters tall. So the angle of depression from something at the top is the same thing as the angle of elevation from the ground. So my angle of depression from the hiker to the boat is the same as the angle of elevation from the boat to the hiker. So we have the opposite and the adjacent sides. So we're going to be using tangent. So we have tangent of theta equals 150 over 200. So theta is going to equal the tangent inverse of 150 over 200. So we're going to get that the angle of depression is 36.9 degrees. The biggest thing to remember about angles of depression is they are not the angle at the top of the right triangle. That's a very common misconception with angles of depression, that they are the other angle in the right triangle, and they are not. Let me know if you have any questions about word problems with trig ratios.